Oh my god. This is the moment we've been waiting for, guys. It's time to solve 3 pentated to 2. Now, if you're really curious, the first 2 attempts, I thought I got it wrong, but I actually got it right. But I actually want to show you guys how I did it. So, wait. The first 2 attempts, the first attempt, I got it wrong. I thought I recording it, I would show it to you guys how I did it. But, of course, I got it wrong. And on the second attempt, I didn't record. Yeah, I forgot to, but I did get the right answer. So for this attempt, I'm going to be trying and get the right answer and showing to you guys and proving that I can do 3 to pentated to 2. I am the smart math person. So let me put the title first. Solving 3 pentated to 2. Yeah. Well, this is how I write it. Now, if you're wondering, this is not the original. This is not the original expression for 3 pentated to 2. It's just 3 arrows pointing up with 3 and 2 on the outside. But I actually don't know how to do that, so I'll just use these 3 symbols. Like, yeah, this one. So let's start by putting in the first expression. Now, this is a pentation equation. Now, this number right here is 2, which will be the pentant, and the base is 3, which we will be using as a conversion for the previous operation. Now, the operation before pentation is tetration, and the tetration equation, it's basically just 2 numbers with 2 arrows pointing up between. So it looks more like this. Now because you're pentating 3 to 2, it's the same as tetrating 3 twice. So it's gonna be 3 tetrated to 3. Now what about tetration to now what do you think? The operation before tetration. It's not triation, it's exponentiation. Or you could call this a power tower. Because you're tetrating 3, because it's 3 tetrated to 3, you're going to do you're exponentating 3 thrice, or 3 times. So it looks more like this. How many numbers? 3. And it has these only 1 symbols. Now let's try to solve this. Let's try to solve this third equation. Now you might think it's possible to convert this into multiplication, but multiplication is way different than exponentiation. It looks more like this: 3 times 3 times 3, because the equation has 3 numbers and it's an uncommon exponentiation expression. Multiplication it's almost impossible to convert this into multiplication. So that's why we simplify some first, so that way we can get to a shorter version. Let's start simplify. Now when you simplify an exponentating equation, and you're writing it like this, you always start from the right. But if you're writing it, you start from the top. And that's what most players usually say about this. So let's start by doing 3 cubed on the top, on the right. So 3 cubed is multiplying 3 times. So we get this. Oh shoot, I forgot to add this. 3 times 3 is 9. And 9 times 3 is 27. Now I told you earlier that you would get 3 to the power 27, but the thing is, because it's 3 to the power 27, you're going to multiply 3 27 times. This could mean that the multiplication equation would be way too long. Now here's to prove it. because you're multiplying 3 27 times, you go 1, 2, 3, 4, 5, 6, 7, 8. Like, bro, oh my god. So 3 to the power 27 is not the easy way to go to. Let's go back. Now, how do we actually solve this? Well, according to the exponent rules, you could just factor out the exponents and use parentheses, and then you can actually separate the exponents with use parentheses, and smash the first exponent and the base together. So here's what I mean. Let's take the first 3 inside the multiplication equation. We can rewrite it as 3 to the power 3, while the other would be just 3 times 3. Notice that in this equation there are 4 3's. One is the base, and the rest 3 is the exponent. This right here is this expression right here is still the same as this, and it still has 3 fourths. We're just using parentheses to move the exponents. It's like the reverse of smashing. So let's try to solve 3 cubed again. We know that 3 cubed is just 3 times 3. So 3 times 3 times 3 to the power of 3 times 3. Now, we already know that 3 times 3 is 9 times 3. Let's rewrite the equation. And then 9 times 3, that's 27. So now we get 27 to the power of 3 times 3. Now, you might see we could just solve 3 times 3 again, but we will lead to the exact stop. The exact stop as we literally went for, as the same as 3 to the power 27. It's called 27 to the power of 9. It's basically the same as 3 to the power 27. So, and if you try to convert this into multiplication, well, it'll still take too long, but it's still writable. Like, watch. Look how long the equation is. There are 9 27s multiplied all together, and this is gonna take too long to be simplified. So let's use the same method as I mentioned earlier. So 27 cubed to the power of 3. 27 cubed, that's just 27 times 27 times 27. Now for master mathematicians, this is basically a little bit simple. Let's try and use distributive property on 27 times 27. Now, I actually learned distributive property at school. So, 27 times 27, this is basically the same as 27 times 20 plus 27 times 7. And then you can't forget another 27. Let's count the parentheses. Alright. Now, when you're using distributive property, you're gonna break down 27. You're gonna break down 27, and then take 20, then duplicate the 27 into double, multiply it, break down the sum, separate the sum, and drag them correct way, and you get this: 27 times 20 plus 27 times 7. Now let's try to solve this. Now, at first I thought 27 times 20 is just 10 times 2. So I broke down 20 to 10 times 2. Now, basically, when you're multiplying a number by 10, you just add a 0. Now, let's try and double this number. Now let's try and double this number. But first, I need to write the expression, what I mean. So 27 times 10, that just becomes 270. Now we're at 270 times 2. Now it's actually simple to just double a number. Let's just disregard the 0 and do 27 times 2. Now we know that 27 times 2, that's just 54. It's the same as 27 plus 27. Then we regard the 0 back because 0 times 2 is just 0. Now that we have 540, let's start focusing on the other partial equation. (27 times 7). Let's use the same distributive property. 7 is just 5 plus 2. Let's count the parentheses. 1, 2, 3, 4, 5, 6. Alright. So it's the same thing. Same distributive property. Now 27 times 5. Do you guys know what the answer is? Well, I might tell you. You want to know what I thought about 5? I thought that 5 was just 1/2 of 10. And I was actually right. So I rewrote 5 as 10/2. So I rewrote 27 times 5 as 270 divided by 2. Because 5 is just 10. 5 is just 10/2. And you can basically just turn 5 into a fraction. And so the numerator and the denominator. The numerator would be 10. The denominator would be 2. So when you're multiplying a whole number by a fraction, you always multiply the whole number and a numerator. The denominator can act as a divisor. You'll see what I mean. Alright, 27. So it's basically just simple when you're dividing by 2. What is 2 divided by 2? That's just 1. 70 divided by 2. Well, that's a tricky one, but it's 35. 77, so 72 divided by 2 is 1. 70 divided by 2, that's 35. Now what about 27? Now what about 27 times 2? Well, I know what you're thinking of. You're basically doubling 27. That's just 54. Now we can do 135 plus 54, which sums up to 189. Now what about 540 plus 189? Well, let's try to solve this in place values. 0 plus 9 is 9. 54 plus 8, that's 52. And 6 plus 1 is 7. So we get 729 times 27, then the expression cubed. Now let's use that last multiply by 27 before we move on to cubing. Before we move on to cubing the final answer. Let's use the same distributive property. Break down 20 again. As I mentioned earlier, 20 is just 10 times 2. As I mentioned earlier, multiply by 10 with a whole number, just add the 0 at the end. Now, multiply by 2, get this. So, 29 plus 29, that's 58. 7 plus 7 is 14. So we get this. Now what about 729 times 7? Well, as I told you earlier, 7 is just 5 plus 2. And let's use the same distributive property. One, two, three, four. 1, 2, 3. Now, as I mentioned earlier, 5 is 10 is half of 10. So let's just divide. Multiplying a number by 5 is the same as multiplying it's now multiplying a number 10 times larger than a dividend and divide by 2. So 7,290 divided by 2. Now 72 divided by 2, that's 36. And 90 divided by 2, that's 45. Now we know that 729 times 2, that's just 729 plus 729. 29 plus 29, that's 58. 7 plus 7 is 14. add 3,645 plus 1,458. 5 plus 45 plus 8, that's 53. And 65 plus 5, that's 70. 37 plus 4, that's 41. 4 plus 1 is 5. Now let's try and solve this huge addition equation. So 0 plus 3 is 3. And then 5 plus 1 is just 6. And 14 plus 5 is 19. Now we get 19,683 cubed. Uh-oh. Looks like we have to solve this last exponentiation equation. Let's break it down. Now you might be wondering, how am I going to solve this 5-digit equation with 3 numbers? Well, we're going to use distributive property again. Now you might think it's not possible, but I'll prove to you that it's still possible. Now here's what we can do. We can just sum out each number inside the parentheses and multiply them with its base. So let's sum out 10,000. Let's sum out 10,000 first. Now you want to know what I figured out about 10,000? 10,000 is just 10 to the power 4, which is the same as adding 4 zeros to the end. So I figured that 19683, it just becomes this. Now let's factor out 9,000. I wonder how that would look like. We're gonna show you. So 19683 plus because inside the parentheses we're summing up. If we multiply them, we are still summing up. We're not multiplying them. So it just becomes 196,830,000 plus 19683 minus 19683. I mean, 9 is just 10 minus 1, so I can just plug that in. So I can just plug it in for 19,683. So it's like 10x minus 1x, and then I just get this. Then I have to multiply the sum by 1,000. Since 9,000 is a multiple of 1,000, followed by 9, which is 10 minus 1, I just factored the 1,000 out to get 1,029. I found a method for 9, so I plugged it in for this sum, which left me with this sum multiplied by 1,000. Let's simplify it together. Right. Let's start using the subtraction method. So 30 minus 3, that's 27. 82 minus 8, 74. 67 minus 6 is 61. And 96 minus 9, 87. 8 minus 1, that's a 7. So we're left with 177,147 times 1,000. 1,000 is just 10 cubed, or 10 to the power of 3, which is basically the same as adding 3 zeros as the digits to the end. So let's add the 3 zeros. Now we're going to find the sum of the two expressions. No, of the two numbers in an expression. Right. So 0 plus 7, that's 7. 3 plus 4 is 7. A plus 1 is 9. 6 plus 7, that's 13. Carry the 1, get 23. 0 plus 7 is 7. And 2 plus 1 is 3. Let's cancel this out. Alright, let's factor out. Let's pull out. Let's pull out 600. 600 is next. Now, yeah, the same method for 6 plus 1 is just 6 is just 5 plus 1. Notice that the 5 method is 10 divided by is 10x divided by 2. So so like 19,683 times 10, that's 196,830, and divided by 2, and we're going to put that divided by 2 plus 19683. Since you know it's 19683 times 1. And since 600 is a multiple of 100, I factored the 6 out so I can get 6 times 100. Use the method, use distributive property and put the method in. So I'm left with this expression times 100. Alrighty. So 19683. This is a hard equation, but we'll solve it. 30 divided by 2, 15. 8 divided by 2, 4. 196 divided by 2. Well, if you solved it correctly, that's 98. Yeah, it is 98. Yeah, it's correct. Let's find the sum for this. And 15 plus 83, that's 98. And 84 plus 6, that's 90. And 99 plus 19, that's just 110. No, 118. So let's multiply that one by 100. So 100 is just 10 squared, or 10 to the power of 2, which is the same as adding 2 zeros to the end. So 118098000. Let's find the sum for this one. 0 plus 8 is 8. 77 plus 9, that's 86. Let's skip this one because we're adding a 0. And 39 plus 8, it's 47. And 74 plus 11, that's just 85. Oh shoot. Let's pull out the 80. So let's see here. 80. So I'm gonna factor out 8 from 80. So we got 8 times 10. Now I honestly thought that 8 was just 2 cubed, which is the same as 2 times 2 times 2. So here's what I did. I did 19683 times 2 cubed. Then I'll multiply it by 10. So let's rewrite 2 times 2 to the power 3 as 2 times 2 times 2. Let's try to solve this one. So 19683, same as 19683 plus 19683. So 3 plus 3 is 6. 68 plus 68. 136, carry the 1. Carry the 1 here. 19 plus 19. 38, add the 1. Get 39. Alright, so let's use the same thing. 66 plus 66. 132. Carry the 1 here. 3 plus 3 is 6. Add the 1 and you get 7. 39 plus 39, that's just 78. Let's go ahead and do this last multiple too. So 32 plus 2, 32 times 2 is 64, and 87 times 2 is 174. Carry the shoot, and 77 times 2 is 14. Add the 1, get 15. I forgot to add the parentheses. So, again, add a 0 at the end when multiplying by 10. 17157 4640. Now let's sum these two numbers up. So, 0 plus 4. 68 plus 6, that's 74. 87 plus 4, 91. And 79 plus 7. Yeah, that's just 86. 58 plus 5, 63. And 6 plus 1, 7. Let's sum out this last one. Is 3. So it just becomes 19683 times 3. Now let's try to solve this one. So it just becomes 1 plus. So d plus 3 is 6. 36. So carry the 1. Alright, that's for this one. Let's do it again. 6 plus 3 is 9. 36 plus 8, 44. 39 plus 4 is 400. And then 40 plus 19, 59. So let's sum these up. Well, actually, we're going to drag this 19,683 to the right. 6, 6, 1, 4, 0. So 4 plus, so 89, and that's yeah. This one just becomes 70. Well, this one is just 42. Oh shoot, I picked the wrong number. So yeah, we have this equation. Now let's do this again. Let's do this again. Let's do this. Rápido agora. Now, just like what we did here, we're gonna use the same thing, but with a gigantic number. Let's sum out. Let's sum out 10,000. And basically, that's just 387 420 10,000 10 to the fourth. Add 4 zeros. 1 2 3 4. Alrighty, I'm on track. That's about 9,000. Alright, 1 2 3 4. This is just recent. 7 42 49. So minus recent. That's whatever 10. The equation is so long, bro. I don't even know why I'm doing this. Well, let's find the difference for this. Oh, what? C 7 4 0. Yeah, that's that. So 489. Let's try to do this. Oh my god. So 90 minus 89. That's just 1. This one is 4. 22 minus 2. That's 18. 37. 66. 78. Wait. we'll bring back this. Well, let's bring this back. Oh my god, I'm getting confused. Well, wait, I should not be confused. So I already noticed this. So 66, 78, 3. So those 4. Okay. So we just found the difference. Let's go ahead and multiply this by 1000. Yeah, add 3 zeros when multiplying by 1000. Can't believe I'm doing this so quickly. Let's sum this up. Let's get this part. 9, 8, 9, 80. And this one is just 96. 43 and 3. Okay. Oh, we're reaching this. We're reaching the 7 trillions. Let's sum out 600. Make sure you're following along, so that way you'll know. Um, 3, 8, 7, 4, 2, so, oh, this. Alright. Plus 3, 7, 4, 2, 49. Then multiply 100. Yep, this is basically right. I don't know how long. No way. Let's try and divide this by 2. This one is just 19. This one is just 37. 1. Alright, so Zero 99 to 91 together. Easy. I swear to God. Alright, so let's try it. So 49 plus 9. That's just 54. And 49 plus 8. That's just 53. 250. Bro, stop. Okay. 9. And then a skip. And you get 12. Get a 52. This is just 44. And this is. Wait, what am I adding? Oh, this should be easy. Wait. 2s are 2. 3. Okay. Nah, do not know if I got this right. No, I actually know that I'm right. We still have to multiply by 100 though. Oh, I got the 0. 2d2. This is 2d2 4 5 2 to the 4 2 to the knife 0. Okay, come on, bro, stop. Alright, let's sum these up. Alright, 2d2 4 5 2 2 9 d4 0 plus 4 is 4 plus 1 plus 3 is 4. 20, so that's 38. 3, I was about to say, bro, 58. This is just 91. 4, 3, 9, 5. Oh, I am getting close. Well, guys, you think I'm actually gonna get a right answer? I do not know. 3, 4, 4, 1, 5, 8, 4, 0. Let's see if I get it right. Did I write it right? I type it right. I'll see. 3, 7, what is your times 2 to the third. Because 8 is 2 to the third. Two times 2. Times 2. If y'all reminded me about my mistake about 100 being 10, thank you. It's 38740 bro. So 978 E4. Alright. Yeah, this one. It's fine. This is 1956. 968. Alright, let's see. Alright, 154968195 And oh my god. Wanna see if this is right. Let's see. Let's see. Yep, I'm right. Let's go ahead and multiply that. 99363910. I wonder if I'm actually gonna get this right. Because I doubt it. Come on. These are 99363910. This and then this and this. This is this. This is just 62. Oh, I forgot to add the C. Alright, 222, 5, 53, 6, oh my god. 7624435223620 plus 370.9 times 3. Oh my god. 387420489. 387420489. 387420489. So let's do the same thing. A7. Now I don't actually know if this is correct, but we're gonna try. Alright, let's try for the moment of truth. Wait, let's try resolving that again. What was that equation again? 387420489 plus 387420489. Will it give me the same answer, or am I just wrong? Wait, let's try that again. Alright, 70. So that removes this part. Let's try again. What's 78 plus 9? That's 87. Right? And I'm skipping 2 digits. So I'll be do 84 plus 2, that's 86. 52. Oh, yeah, add 7. 82. 86. And then 11, 16. No, wait, it gave me the same answer. Oh, what did I do wrong? But that's what. Let's check. Oh, I think I know, right? 4 plus 1 is not 6. It's 5. Let's change that. So, my bad, guys. I got it wrong. It's okay. For the moment of truth, let's try and solve this. So 20 plus 67, that's 87. That's 9, 4, 8, 4. Like, bring back the... Did I do that? No, it's 37. 97. And then add the 2 ones to get 2... Oh my god. Alright. Let's see if I'm right. So to test this, I'm gonna open up Chrome. And to see if I actually got it right. Let's see if my math is correct. Nah, I don't know why I closed out. Let's try again. Alright. And let's see. So let's use... So I already know that 3 pentated to 2. Oh my god. Oh my god. Bro, look. Oh my god. I actually got it right. Yo. I got it right in under an hour. I got it correct in under just an hour. Holy. Holy. Oh my god. 7,625,597,484,987. Oh my god. Oh my god. Yo. Wow. I didn't know I would actually get a right answer. Woo. Well, I guess I solved it. Thanks to all my thanks to all my intelligence. So I solved the pentation. I solved a I solved the pentation equation. Let's do this. Woo.